Hi guys, so today I will be showing you how to set up a LangGraph workflow for Agentic RAG and how we can run and connect an Ollama embedding model and chat model with the LangChain, and how we can create this LangGraph workflow. So the problem with traditional RAG workflows is it fires the retrieval on every prompt. Means even if it is a casual talk or small talk, it will try to fetch the data from vector-DB, and it will try to give you the response. So what I have done here is you can see the LangGraph workflow in the screen. So first, whenever a user asks for something, it will first check is it a follow-up prompt or follow-up query or anything like that, and then it will go to the generate initial answer node. There we will determine whether it is a casual talk, or is it a query related to historic information, or is it really need searching in the vector DB. Means if it is a new query, it will go to the vector DB and search for the related data, and it will fetch the data, and for generating the final answer, it will take that data. So from historic response and run tools, it will go to the final answer node, and it will finalize the answer, and then it will go to a quality gate node. In that node, what it will do is it will check whether the user's query and final answer is sufficient or not. So if it is sufficient, it will end the workflow. Otherwise, it will rerun the whole workflow again and again until it gets a maximum threshold, or whenever it get a sufficient answer. If it is a casual query, then it will go to the casual response mode, and it will give a casual response. If you are asking hi, how are you, then it will detect that it is a casual query, and it will go to the casual response node, and it will give the response accordingly. So that is the whole workflow is about. I will quickly go through the code, and I will show you the workflow and how I have set up it in the local machine. So if you see, I am not using any internet or anything. Both the chat response model and embedding models are running in my local system. So I will quickly show you what models I am using. So I am using Ollama. I will type Ollama list. So right now, based on my system specifications, I am using two very small models. So I'm using this Gemma 3 latest for chat completion, and embedding Gemma latest for as an embedding model. Why I'm using this chat completion model? Because for my system specification, I can seamlessly run models like this only. So in those models, I have checked with multiple models, but in those models, the problem is most of the models doesn't return the structured response. Means I need JSON structured response in different locations for creating the conditional edges. So I found only this model that returns a better structured response, JSON response. So that's why I'm using this model, and I'm using an embedding model. You can use any embedding model. So what I have done is, first I have set up the LLMs, and here you can see I'm importing the chat Ollama and Ollama embeddings from LangChain Ollama package, and I have initialized both the models here. So you can access both the models from the same port. You only have to change the model name. If you are pulling another model for your use case, then you only have to change this model name. And if you are using any other embedding model, you only have to change this embedding model name. Then it will use that model. So this is just for sanity check, and I will go to the services file. Here what I have done is, I have created a I'm using a incident data. This is the incident data I'm using for creating the vector DB, embedding it into vector DB and creating the RAG. So we will be querying this data. I created this from with the LLM only, Google Gemini, Google AI Studio. Here you can see there are incident numbers, location, title, description, category, and comments and work notes. So I have created some dummy data. So first what we will do is we will extract the contents from that Excel file in a format like this. So this is the format. So we will be using pandas, and using pandas we extract the data like this. We will convert it into strings, and along with the metadata I'm using a document here. So what the document contains is it contains a field called page content, and it will also have metadata. Why I am using this metadata I will show it in the later on the video. So here I am using a document. Inside that document I am giving the extracted and joined string data, and inside metadata I am storing all the fields and its values as metadata. So right now in a single document we have the combined string and the structured metadata of each incident. So I am appending the metadata to an array and I am returning it, and then I am using that metadata, that document to create a ChromaDB vector DB instance. So here what I am doing is I have imported Chroma from LangChain, and I have given a ChromaDB path at the top. You can see I have a ChromaDB path here, and I am importing this Chroma from LangChain community.vector source. Here you can see this is the vector DB path, and this embeddings is the LLM model that I am using. So you have already seen this is the embeddings model. I'm importing that embedding models in the service and giving it into the Chroma function. So it will automatically create a vector DB for me, and I'm ingesting my documents. The documents I have created in the previous function, I'm ingesting the documents as a bash to the vector DB. So you can add the documents using this vector so.add documents. Here we have created the vector so, and we will be adding the documents here, and so that my vector DB is set up. So you can see that here is a vector DB folder, and all the embeddings will be kept in that folder. So it is a local setup, and this is the I have written another function to load the vector DB. It is for querying purpose, and this is for this will return the vector store itself, and this is for getting the documents for our query. So what we will pass the query here, and or the incident number here. If it is an incident number, it will fetch the incident based on that number. For that we are using that metadata. Why I am using metadata filtering here is because if you are asking for what is there in incident number 1000, it doesn't know what you have meant by this 1000. Means it is searching semantically for the incident 1000 in your vector DB. So there might be incident number 1001 there will be there, 1002 will be there, and etc will be there. So there is no guarantee that it will fetch the incident 1000 for you. Means it may fetch incident 1001, 1002 or any incident, because it is searching semantically. These 1001, 1002 is semantically similar, and it will be plotted in the vector DB plane in the same location. So there is no guarantee it will fetch the right incident for you. So that's why I'm using metadata filtering search here. So if there is a incident number provided, then it will fetch the incident number based on the metadata that we have appended. So here you can see it is appending a condition, incident number, and based on what incident number you have provided, it will fetch the incident. Okay, and the otherwise it will fetch only the other incident based on semantic similarity. Okay, and it will return all the documents, means it will return an array of page that documents containing page content and metadata. Then this is another node, another function that I have created. This is only for giving feedbacks to the system. Currently I'm not using this. We will be focusing on mostly on the RAG part. So here if we go to the workflow, I have several nodes and edges. So the nodes means simple functions. So you are writing simple functions, right? So we can give that simple functions as nodes, and we have to set up, after adding the nodes, we have to connect it with edges, and we have to compile the graph. So I will show you how the nodes and edges are created and what is the underlying code for this. So here you can see I have imported a state graph from LangGraph and an end node from LangGraph. Then here you can see I am importing custom nodes that I have created from nodes folder, and here I am using a memory saver. I will come to that. And why I am using a state graph, we have to store a state somewhere, so that after each node execution we can store the latest state of the execution in the graph state. So here if you go to the graph state, this is similar to a state in if you are familiar with creating React applications or something, there also you are using state, right? It is for storing the state. So here if you can see, this is the state class. So inside that class, this is the query. So whatever the user asks, we will store that user's query in this variable, and this is for checking whether the query asked is a follow-up or not. We will store that details here. This is the previous chat history. This is for previous chat history. What it will do is it will keep a list of previous chat history as human message and AI message. So this is a custom function that returns the last 10 chat histories, and this is the answer variable. So here we will be storing the final answer. This is an initial answer variable. We will store the initial answer after initial node execution. What it contains are it will contain the query type, whether it is a casual query, historic query, or whether it really needs the vector DB search or not. And the search queries are, the LLM will generate some search queries based on the user's query. That is for fetching more incidents or giving a more robust insight. So this is the list of incident numbers. Means whatever incident we ask, it will list out those incident numbers to pass to that function to fetch only those incidents. And after that we have references. This means we will store all the references. Means after fetching content from vector DB, we will convert it into a string and store it in this references variable. And this is for verifying whether the generated answers are sufficient or not. If it is sufficient, it will say true. If it is not sufficient, it will return false. And this is a reflection. Means it will say what it is lacking in the uh, last generated answer. If it is insufficient, it will say that answer doesn't contain this information, and this reflection string will be passed as the new query for the new graph execution. Means that after the quality check, the new reflection will be passed from here to here. So in new graph execution, we are not using the same query that is asked by the user. We will be asking the query that is that came from the quality gate as a reflection, and we'll be passing it as a human message here, and we will ask that query here. So it will multiple times it will do the iteration, and it will generate the answer. So hope you got an understanding of that, and I will go to the nodes and chains. The nodes contains all the nodes, you can see the nodes here. These are the nodes, contours, final answer, these are the nodes. So this contains the functions. All the functions will accept the entire graph state. Means we will be storing the state of the graph in the graph state, right? So that graph state will be passed down to all the nodes, and it will return the we can either return the complete graph state by modifying it inside here, and we can either return the complete graph state, or we can return the updated value only. The only condition is that this return values should be there in the graph state. So first we will run the check follow up. So for it will check whether it is a follow up query or not. For that I have a follow up chain. So I'm using a prompt template here, and I'm using JSON output parsers and Boolean output parsers. I'm importing the Boolean output parser from LangChain, and I'm also using JSON output parser and string output str output parser. JSON output parser is for getting the data as a JSON response, and str output parser is for getting the data the answer responses string, and Boolean output parser is for getting the responses Boolean values. So for the first node, for first follow up node, we only need a value true or false, right? So here for the follow up chain, I'm using a chaining method here. I'm using this prompt. What it will do is it will check whether it will use the chart history from the state, and it will use the query of what user is asking, and it will check whether it is a follow up query. Using the chart history, it will check whether it is a follow up query. If it is a follow up query, it will say yes, and it will return true, otherwise it will return false. So and the second node, what I am doing is this is the conditional, this is what makes the flow conditional. So the response from this node will be stored in the state. Means in this node we will check whether the user's query needs search, or is it capable of responding with the history, or whether it is a casual talk. If it is a casual talk, it will only return that response only. If it is historic, it will respond based on the previous chat history. If it really needs a search, then only it will go to the vector DB and search the data, and based on what it got, it will return the response. So that is the first responder, and these are for this is for casual chain. If it is a casual query, it will use the query and chat history, and it will give a casual response. For that I am using this chain. This is the history aware chain. In this, what I am doing is I am giving the query here, chart history here. This references is the fetched content from RAG. So based on all these data, I am returning a response, and I will be storing it in the answer, and after that we will check whether the returned answer is sufficient or not. in the quality gate node, and we will I am using this chain for quality gate. So that is the whole workflow. I'm importing all those nodes here, and I'm connecting the nodes with edges here. So here you can see I'm setting the entry point as follow-up check, and from follow-up check I'm going to the generate initial answer. So I'm adding an edge to that from follow-up check to generate initial node. Then I'm using a conditional edge. There I am from initial answer node, I'm using a function called should continue. What this should continue contains is I'm taking the graph state in should continue node, and I'm taking the initial answer of query type. If it is casual, then it will return casual. If it is need search, it will return need search. If it is historical, then it will return historic. So in the workflow, we will get casual, historic, or need search from should continue function. If it returns casual, it will go to casual response node. I have already shown a casual response node, so it will go to casual response. If this should continue returns historic, it will go to historic response node. This is the historic response node. If it returns need search, then it will go to run tools node. Then from here I am adding edge from casual response to end. Means if it is a casual query, then we can end the workflow. From historic response I am connecting it to final answer. From run tools also I am connecting it to final answer. Means we have to check whether the final answer is fine or not, right? So from the final answer I am connecting to quality gate node, and from quality gate we will add another conditional edge. If it is not sufficient, then it will again go to the follow-up check node, the first node. Otherwise it will end. Okay, so that is the complete workflow, and I will show you the result of this. So I will quickly run this. So I'm coming here, and I created it as a fast API server. So I forgot to mention one another thing, that is the memory. So right now we are storing everything in this graph state, right? So this graph state is not persistent, means it won't be there even after the execution. This graph state only available throughout a single execution. Means after a single graph workflow, this graph state will be erased. So we need something else to store the memory, right? So that I am using a memory saver. It is a simple memory saver. So this I'm importing it from LangChain.checkpoint.memory, and while compiling I am giving this memory to the workflow. So that even after the execution, the memory will be stored for each user. Means after an execution we will get a session ID for the same user. If we pass the session ID again and ask something, it will take the data from this memory also, and it will, while providing the response, it will use the memory. So I'm going to this fast API endpoint. I have created an endpoint also. This is my fast API server. I have created endpoints for this. One is for searching documents. I have imported the whole graph workflow here, and I'm calling that graph, invoking that graph here, and passing the data here. And this is the user's message only, and this config contains the thread ID. So if you have a thread ID, then it will directly pass the thread ID here, and it will take the data from memory also. If you are running it for the first time, it will generate a thread ID and give it to you. Okay, So that is the workflow. I have also added an incident feedback node here. That is not required now. You can try out once you get this code. I will push everything to my GitHub repo. You can take it from there. So I will quickly run the entire workflow. So this is the data I'm using. So here you can see there is a file sharing issue. So I'm asking a query related to that file sharing issue. So I'm clicking on execute. You can see the running here. First it will go to the initial node and check whether it is a follow-up. In my system it is a bit slow, so that's why it is taking some time. So it has went to the initial answer node. From here we will find out whether it is a historic, casual or need search. So it has find out that it needs search. So it searched in the vector DB and fetch all these documents, converted it into string, and it is generating the final answer right now. Okay, so it has entered the workflow after getting the final answer, whether it is sufficient or max revisions reached. It has entered the workflow. We can see what we have got our response. So you can see here it is returning these file sharing issues identified. It is saying that there is an incident 1000 with the file sharing issue. So it is returning returning this incident. This is incident 1000. So it is returning this. I have given to return two top incidents from the RAG DB, vector DB. So that's why it is returning two incidents. Right now you can see it is returning the incident 1000 and it is returning the data related to those things. So this is the documents. This document containing this data. It will also return the reference document also, and it will return a session ID. It is created by the system only. So we can copy it and we will paste it here. In the initial run we haven't pasted any session ID. For now we will paste the session ID and we will ask the query again. So right now it has the historic information. We will see whether it will take the historic data to reply for this. Okay, so it has identified that the historic data contains the response for this. So it returned the historic here and it is going to the historic workflow right now, and it will generate the answer based on historic information. So this is the workflow. Here in the initial running we run without the session ID, so that it went to the need search node and it generated the response, and after quality checking it returned the response. Right now it has the historic information for the same incident, so it is going to the historic data after checking whether it is a historic, casual or need search. It is going to through this workflow, and after quality check we will get the response. That's what is happening right now. After this we will check a casual message also. Okay, so it has returned the response based on right now it haven't done any vector DB search, so the document array will be empty, and right now it is returning the response based on the historic data. So you can see here it is returning the incident from the previous history, chat history. I will run a casual talk also. I will ask, hi, how are you? So I'm asking I'm just writing a casual message here, and I'm going to execute the flow again. We'll see what is happening. In traditional RAG systems, what happens is, even if we ask hi, how are you, then it will check the VectorDB for this query also, and it will return you the search results. So here it is more like you are chatting with the LLM. So if you are asking a casual message, then it will only return a casual response. Otherwise, it will go to another flows. So you can see it has identified the message is a casual message. It is going to the casual answer chain, and it will generate a casual response, and it will return it to you. Okay, the flow is completed. See, you can see here it is returning a casual message. So like this, I have built this Agentic RAG workflow. So this is a custom workflow. You can also add more data or more fields to the graph state and try it with your own thoughts, and you can build your own workflows also. So this is all about this video. Hope you liked it. If you like this video, please do subscribe and share this with your friends. Thank you.